So the next operation we have on arrays is deletion. So now in order to delete an element, let us consider we have some elements like 1 2 3 4 and 5. So now if we want to delete the element 4, then the resulting sequence would become 1 2 3 5. So now if you observe, let us think this sequence as an array, and the indexes starts from 0 1 2 3 and 4. Now when you are going to delete the element, the resultant array would look like this: 0 1 2 3. That is, when you delete an element, the deleted element index will be occupied with the element in the next index. This 5 will be occupying the position or the index 3. So likewise, if you have the elements 6 7 8 9 and 10. So see, if you have the elements like 1 to 10 elements, and now you want to delete the element 6, then your resultant array would become 1 2 3 4 5, and as we will delete 6, we will not have 6 here, 8 9 and 10. So if you observe the indices here, 6 7 8 and 9, so 0 1 2 3 4 5 6 7 8. So once you delete an element here, all the elements you observe the index of 7 is 6 here, whereas 7 after deletion of 6, the next element index become -1, next element becomes -1. 8 here is 7, position of 8 is 7, position of 9 is 8, whereas here position of 8 is 6, and then position of 9 is 7, 10 is 8, previously it was 9. That is, when you want to delete an element from an array, then you need to move all the elements after the deleted element to one position front, to one position left, or one position front. Okay, then you will get the resultant array. So now let us write an example program that takes all the elements from the user into an array. Ask the user for the position to delete. That is, say for example, you have 10 elements, and I'm giving position 5. That is 1 2 3 4 5. So this number 5 has to be deleted. So element at position 5 has to be deleted. So fifth element, in order to delete position 5, we need to take the position into a variable from the user, and then array elements from the user. So I need to delete the element given by the user position. So that position element I need to delete from the array. Say for example, how we'll write the program is, so I am directly initializing the array 10 20 30 40 50 60 70 80 90 and 100. So total we have 10 elements in our array. So now you need to take the position. So in order to store the position of a value to be deleted, I am taking the variable POS, int POS, and then in order to access the elements we need an array. So for that array I am taking the value variable I. Okay, so then now let us see, we need to take the input from the user, that is which position the user is about to delete. So for that I am writing just a printf statement. Enter the position of the element to be deleted. So after taking the position, then after printing the message, you need to take the input. So for that I am writing scanf statement, %t comma ampersand POS. I am taking the value into the variable POS. Then after you get the POS, now if I give the I need to eliminate the fifth element, this, and when you see that the index of the element 5 will be 4, 0, 1, 2, 3 and 4. The index of the element fifth element would be 4. So for that purpose, if at all, if I give the fifth element the position 5, I need to make that value as 4, because the fifth element's index will be -1, that is 4. So whichever the position, if I want to eliminate that last element, then its index would be 9. If I want to eliminate the 10th element, that index would be 9. If I want to eliminate the 6th, the 7th element, then its index would be 6. So for that purpose, I am reducing -1 from the value given in order to match this value with the exact index value. I am making this position -1, decrement operation. So after this, now we have the position which of the element which we need to delete. So then for I is equal to 0, I less than n, I plus plus, see here, if you observe from where we are going to move the elements 1 before its index, one element to its before index is when we meet the index that is matched with the position given. So now if I want to delete element 4, if my index value is equal to 4, then the element after that position value or the position index, after that index I need to move to front. So if I value is greater than or equal to p, then what we have to do is we need to move the element I plus 1 into the element I. So next index element should be moved to the previous index. So if I greater than p, that is if my index is equal to the given position, or if it is next to the remaining, if it is after the given positions, then you need to move it an index before. So a of I is equal to a of I plus 1. Okay, so then if it is not, if I is not greater than p, that is if I is 0, then we need to print the starting elements with where until and unless we meet the position p, we need to print the elements as it is. The array element should be as it is. So printf %d comma f. Okay, so now after printing the 3 index up to 3, then in next iteration I will be equal to 4, which is equal to the value p. Then in the fourth index, fifth index element will be assigned, then you will be printing the a of I, the fifth index element, leaving the fourth index element. So likewise you can delete an element from the array. So the next operation is insertion. So in order to insert an element into an array, we need to shift the elements. Say for example, we have the elements 1, 2, 4 and 5. Now we want to insert an element at position 3. So 1, 2, after 2 we need to insert 3 and 4, 5. So if you think this as an array, 1, 2, 4, 5 with indexes 0, 1, 2, 3, and after insertion, so if you observe the elements after insertion, 0, 1, 2, 3, 4. So as we have seen in the deletion, what will be happened is, if you want to delete an element, all the elements after that position should be moved one position left. Now if you want to insert an element, if you observe, the element at index 2 has now moved to index 3. The element at index 3 is now moved to index 4. So if you want to insert an element, you need to take the position of the element where you want to insert, and then you need to move from there. You need to move the elements one position next to the next index. In deletion we are moving one element to previous index, whereas here we are moving one element to the next index. So let us see how we will write a program in order to insert an element into an array. So let us start with main function. I am taking an array of 20 elements and I am going to initialize it with 0. Then some variables. This is to access the elements we need a loop. N for total number of elements to be entered into array. P, position of the element where the element to be inserted, and then the actual value of the element which has to be inserted into an array. So I have taken all these variables. Now first we need to do is, we need to take the input from the user, how many numbers or how many elements he is going to enter into an array. Enter how many elements in an array. So the total number of elements he wanted to store will be stored in a variable. So for that I am taking scanf %t ampersand n. Now total number of elements, the size of the array we got. So now you need to give a message to the user to enter the elements into an array. So enter the elements for I is equal to 0, as the index starts from 0, I less than its size n, I plus plus, scanf %d comma ampersand a of I. So by this statement now we got all the elements inserted into an array. Say for example, I have given the n value as 4 and the elements are 1, 2, 4 and 5. Okay, so now you need to know the position where you have to enter the element into an array. Say for example, after the index 1 at position 3 and index 2. At index 2 I want to enter the third element. So as I want to enter the third element, now you need to take the value of the position. So enter the position to insert. So, and that position value we need to take input from the user, %t comma ampersand p. So since if I give as I want to insert third element, I'll give the input as p is equal to 3. So now p will have the value 3, but we need to, if we want to insert the third value, our index should match with 2. So p minus minus, I am decrementing it to -1. So now the p value will become 2. So after getting the value p value, then you need to do that. So you need to from this after knowing the position, now you see if you move the exact position element to the next, we are going to miss this element. Okay, so for that purpose what I am doing is 1 2 4 5, and as we have declared num of 20 here, we'll be having 20 elements memory given to our program. So in that we have used only 4 elements by giving the n input value from the user. So now what I am doing is from the nth element, I am going to move it a position back. Then it becomes 1 2 4 5, and then this will be copied to the next element also. It is 5. Now in this position I'll move 4. Then the array becomes 1 2 4 4 and 5. So now if you see the position or the index 2 where we want to insert the element, that element is already copied to the next index. Now you can insert the element where you wanted to, in which the position you have given. So until, if you observe, until when we need to repeat the action of moving the elements to next is from the last element until we reach the value of p. Okay, so from the last element until we reach the value of p, we need to move the element to the next position. So for that I am using the for loop. So as I am going to move the elements from the last of the array, I am taking the value of I as n. Okay, if you observe, we'll get, if we take the value of n as 4, we are going to get the indexes from in the range 0 to n minus 1, but we are taking the I value as n because here this is n minus 1 position. We are going to move the n minus 1 into next position, that is n. So I am considering it from the value n, and until my I value is not equal to p, and we need to decrement. After moving this element here, we need to come one step before and then move this. So if our index is this, in next iteration we need to reduce our index, so I minus minus. Now what we have to do, first array a of n should be moved to a of n minus 1 should be moved to a of n. So a of n value is present in I, so a of I is equal to a of I minus 1. So with this repetition, all the elements will be moved until it reach p. Then the array becomes like this. By the end of this loop, your array becomes like this. Then after getting the array, after moving all the elements one index to right, then now we need to insert our element. So our element is at position, we need to insert the element at position p. So num of or a of array of p is equal to the element which we want to insert. Okay, after after getting the position, here you need to take the input for the element also, which element you are going to insert into the array. Ampersand, I am taking it into the element ELE. So that ELE, the element which I wanted to insert, I am assigning it to the array at position P. So after this, you can print the final array after insertion. I less than or equal to n. Now you need to write less than or equal to n, because if you write less than n, you will be accessed only n minus 1 elements. Now as we have added one more element to the array, our final size will be equal to n and then I plus plus. So printf %t comma a of I. Okay, so like this you can insert an element into an. So the next operation we have on arrays is searching. So searching in the sense, when you have a set of elements with us and we want to find out whether a particular element is present in an array or not, then we'll go for searching that element in an array. So in order to search an element in an array, we have two methods. One is linear search and the other is binary search. So in linear search, linear in the sense the name itself indicates that we'll search the element in an array in the sequence. So we'll search all the elements from the starting of the array until we reach the end of the array. If we find out an element in the array, then we'll stop searching. Okay, so say for example, linear search. In linear search, so you have some 8 elements within and you're going to search an element. Say for example, you're going to search an element 6. So you need to take the input from the user which element he wants to search. So after taking the element as input, now you need to start comparing this element with the elements in the array from starting. So 6 compared to 1, it is not equal. If it is not equal, then you should search with the next element. Not equal, so search with next element. Not equal, search with next element. Not equal, not equal, it is equal. So the element is found in the array at some position. So as we have got our element found, we no need to search the remaining array. So likewise in linear search, we'll start searching from the first element and until we reaches the element that is matching with our search element. Until we reach the element, until we match an element that is equal to this search element, will make our searching continue. Okay, so for this let us see a program now. So let us take an array of 5 elements, 10, 8, 2, 7 and 3, and in order to access the array elements, I am taking an input and I am taking a variable to use in a loop I. This found, I am taking a variable found because initially I am initializing it to the value 0. If the search element found, if the element we are going to search is found in the array, then we make this found value to 1. Okay, and finally if the element is not found in the array, we need to display the user that the element is not found. So to make use to confirm that the element is not found, we make use of this variable. So initially we take, suppose I am taking an element 9 to be searched. So 9 is compared with first element, not present, 8 not matching, 2 not matching, 7 not matching, 3 not matching. So if no element is matched, this found value will be always 0. So at final stage we'll compare the value of found, and if it is equal to 0, then it indicates no element is present, that a such element is not present in the array. So then if we want to print the element at which position we found that element, so to store that we need a variable POS. If you want, you can eliminate this, and then the number, the search element which you wanted to search, the element you wanted to search will be placed here. So now first step we need to do is, which element we need to search, we have to take it as an input from the user. So you present a message, enter the element to be searched, and then we have taken that element to be searched into the variable number, num. So now what we have to do, we need to start searching right from the first element. So for that I am taking a loop for I equal to 0, I less than n, I plus plus. Okay, so here this element which we have to search, suppose it is 9, let us say it is 9. So now the element which you want to search should be compared with the element, with each element in the array. So I'm in order to compare, I'm using if condition, if a of I equal to number. So if it is found, suppose if the element is found with the element in an array, then as we have said, if the element is found, we need to make this variable to 1. So found is equal to 1, and then printf found in position. So the element at index I will be matching with the number, the element we have given. So the position of that element would be its index, that is I. So %d comma I, just a printf statement. Once the element is found, you no need to check the remaining elements. So if it is 9, if it is 10 I have given, in the first iteration itself, in the first comparison, will match the element. So found will be 1, position will print that position, and as we don't need to check the remaining elements here, so we can break the loop. So say for example, if it is not found, for I equal to 0, a of I have given a value 7 in num, say for example. So a of 0 is 10, not matching. All these statements will not execute. Again I is equal to 1. Next element at I equal to 1 is 8. So 8 not equal to 7. Again this will not be executed. And again third one is I is equal to 2, and the value is 2, not matching with 7. These will not be executed. Again I is equal to 3. Now a of 3 is 7. 7 is equal to 7. Condition true will come inside the if condition. Found is equal to 1 and print its position, that is 3. And then break, because as we have found our element here, we don't need to search the remaining elements. So break. Say for example, if I give 9, finally this 9 will not match with 7, will not match with 3, and then will come out of the loop. This found will never become 1 if the element is not present. So finally, after completing the search, you just write if found equal to 0, that is this statement never executed. You can confirm that the element is not present. So found equal to 0, then you can print element not found and close the main. So this is about linear search. So the next method we have in searching is binary search. So in binary search, we'll make the array into two halves based on the middle element. So now let us consider the element we need to search is, say for example, it is 40. The element we want to search is 40. So we'll make the elements, will make the array into two halves. So how we'll make the array into two equal halves is, this will be your beginning index and this will be your end index. Okay, then you need to find the middle element in order to make the array into two halves. So how you will get the middle element? mid is equal to the beginning index plus the ending index by 2. So here middle element will be beginning index is 0 plus ending element end index is 9. So 0 plus 9 by 2. 9 by 2 is, actually we have 4.5, but as they are integers we'll get the answer as 4. So the element at index 4 will become the middle element. So based on that middle element, we'll make the array into two halves. The element at index 4 and the element at indexes 0, 1, 2, 3. And the remaining next half after the middle element, we have 60, 70, 80, 90 and 100. So this is our middle element. These are the positions we have. So now what we will do is, we'll compare the element to be searched first with the middle element. If it is equal, then we'll find a match. If it is not equal, then we'll check whether the element we want to search is greater than the middle element or less than the middle element. So here in this case 40 is less than the middle element. So 40 is less than the middle element because means you need to search with the before half. The main thing we need to remember in binary search is the array should be in a sorted order. Sorting in the sense, either the elements of the array should be in ascending order or they should be in descending order. So see, if you consider it as an ascending order array, so now when we compare with the middle element, our element 40 to be searched is less than the element in the mid. Okay, so less than means we may have the element in the first part of the array. So now you will remove, you will not search the rest of the array. So you consider only the array, the first part of the array where we expect our element would be present. So the index, so the half of the array we considered here is 10, 20, 30 and 40. Okay, now the beginning index will be the 0, same as it is 1, 2, 3. Now the end index will become, when the element is less than the middle element, so array of mid, so it is less than the middle element, then the index which is present at the end of the array will become the element before the middle element, that is end index will become middle element index minus 1. So if you observe, middle element index minus 1 will become your ending index of the array. So now again the same procedure repeats. Now we have the beginning and ending index, so we need to find the middle element again. So beginning plus end by 2, 0 plus end index is now 3 by 2, 3 by 2 integer division will result in 1. So now the middle element is 1, Now you will compare this 40, the element which is to be searched, with the element we found as middle element, so that is 20, and the remaining array is 30 and 40, 2, 3. So now if you see, when you compare it with the element 20, so 40 is greater than 20, right? So greater than in the sense it should be present in the array after the mid element. So now the beginning index, so now the array should be, this half should be considered, and we'll omit these two values. So the beginning, now it becomes after the middle element, so mid plus 1, and the end index will be same as the previous, and end index is 3, so this will be same as the previous one, so end will be this. Now again the array we considered now is 30 and 40, so beginning is mid plus 1, that is 2, and end index is 3. Again find the middle element, mid is equal to 2 plus 3 by 2, that is, the result is 2, so this will be the middle element, so this will be the middle element, that is 30. So compare 40 with 30, again it is greater than 30, then you will take the elements next to the array. So now the beginning of the array becomes mid plus 1, that is 3, and end also will become mid plus 1, 3. So middle element now becomes 3 plus 3 by 2, that is 3. So now 40 will be compared to the array of 3. So what will be the result is 40 will be matched with this 40, and we can say that the element is found. So if we reach until here and if we did not find, suppose our search element is 45, let us think, which is not there in the array. So when you compare this, you already reached beginning is equal to end. So when you compare this, your 45 is greater than 40. So greater than, if you get the greater than, then your beginning should become 3 plus 1. The previous beginning value is 3. So 3 plus 1. Now the beginning is 4, and the end value will not change. If you observe in previous conditions, beginning value changed to m plus 1, but end value did not change when the element is greater than the array element. So end will be 3. So now if beginning is greater than end, then we can say that the element is not found in the array. And at the same time, when the element is found, we will make the variable found is equal to 1, like we did in the linear search. So if the element is not found, then the conditions would be found may be equal to 0 and beginning greater than end. If either of these conditions is true, we can say that the element is not found in the array. So now let us see how we'll write a program using this concept. Okay. Say for example, I'm taking an array A of 10 values. So I'm taking an array A of 10 values, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Beginning index variable, end index variable, and mid index variable, and a variable to make sure whether the element is found or not, and initialize to 0. And then your number, your search element which is to be searched in the array. So after taking the elements, now you need to know which element need to be searched. So scanf %d comma ampersand num. So the element you need to search is given to the variable num. Now the beginning index, when we consider the complete array, the beginning index is 0 and the end index would be, here in this case, 10 minus 1. If you take n values, it would be n minus 1. So directly I am taking it as 9. 10 minus 1, that is 9. So as we have seen, until we get beginning greater than end, that is until we completely search all the elements, we need to repeat this action. So in order to repeat the action, and as we don't know after how many iterations the begin index is going to be greater than end index, we can use a while loop here. So while beginning greater than, so greater than, when it becomes greater than, we need to stop looping. So while beginning less than or equal to end, until it is less than or equal to end, we need to repeat. Once this condition fails, that is beginning greater than end, then we'll stop our iteration. So while beginning less than end, our first task is to find the middle element, beginning plus end by 2. So if a of middle element is equal to the number, then you need to print element found, and you're going to make the found value as 1, as we have got the element found. And then, as we have already found, if the element is matched, we no need to search the remaining array. So we can break this while loop. We can stop executing this while loop. So to stop executing this, I am placing a break statement here. Okay. So this is the case where if the element is matched with the middle element. If it is not matched, else if it is not matched with the middle element, then what we have to do is we need to compare whether it is greater than or less than the middle element. So if a of middle element is greater than the number we need to search, so middle element is greater than the number, that is number is smaller than the mid. So when it is true, you need to search the first half of the element. So first half, in the sense beginning will be as it is, you need to change the end index, that is mid minus 1. Else in the sense a of mid is less than num, then you need to change beginning as mid plus 1. Okay, so with this we'll complete searching. So finally, after searching all the elements, if beginning greater than end and found is equal to 0, then you can say that the element is not found. So like this, we'll perform a binary search of an element.